Okay, so to prove this identity, cosecant negative x minus sine negative x is negative cosine x, cotangent x. Use the fact that cosecant is odd, so we're going to rewrite that as negative cosecant x to start off. Use the fact that sine is also odd, so it's going to be now plus sine of x because a negative sign came out. Negative 1 times negative 1 makes positive 1. So that should be the first step of the proof. Use the odd and even properties. The fact that cosecant is odd and sine is odd. So we got negative cosecant x plus sine x. The rule there is odd even properties. Okay, so we're supposed to, now it's just like a proof that we've done before. Now we're supposed to make the left side equal the right side. We got to somehow combine these terms. So let's rewrite cosecant using the reciprocal definition. That cosecant is 1 over sine of x. Okay, because then maybe we can get common denominators, smush those two fractions together. So that's using the reciprocal. And now we can change sine x to be sine squared x over sine x. Okay, because what I did here is I multiplied sine x by 1, just in the form of sine x over sine x. Okay, sine x times sine x makes sine squared, and it gives us sine x on bottom. So this step was an algebra step. When you multiply the top and the bottom by something so that you're still multiplying by 1, you're using an algebra trick. Oops, that's not what I wanted to look like. That's fraction sine squared x over sine x. That's using algebra. And now we have common denominators. Let's see, I think we're okay here. We got negative 1 plus sine squared x. I often have to stop and think. I was doing a proof just a second ago in a video, and I had to stop it because it was eventually going to get me there. It's just sometimes it can take forever, and there's quicker ways. So I think this is the quickest way. Now we're combining the two fractions, got common denominators. Okay, so we add, that's again an algebra property when you add two fractions together with common denominators. Now this up here, we can go back to the fact that sine squared x plus cosine squared x equals 1. This is a Pythagorean identity. If you subtract sine, actually here, we're going to want to subtract cosine from both sides. You can take a Pythagorean identity and move it around all you want, okay? I'm subtracting cosine squared from both sides. It's a balanced algebraic step. And I'm doing that because I know the next step could be to subtract 1 from both sides. So now I've got a negative 1 plus sine squared x equals negative cosine squared x. So this up top is that negative cosine squared x that we just got from the Pythagorean identity. We just took the Pythagorean identity as an equation and moved it around a bit. So the cosine squared x, it does that thing again, okay. That's over sine x. That's using a Pythagorean identity. And then final step here is, actually I don't know if they're going to want us to break it up in two separate steps. You can say this is negative cosine squared x over sine x, sorry, not squared, times cosine x, right? Cosine x over 1. You can take one of these cosines out and multiply it, because then it's like having a fraction over 1 here. So my next step would be to, I guess let's write it out. I was going to do two steps at once. That usually doesn't go well with Alex. That's just algebra. We rewrote that with algebra, moved a cosine outside, and now we can use the quotient of negative cosine over sine. That's cotangent, okay? Anytime you see cosine over sine, it's cotangent. Okay? Anytime you see sine over cosine, that's tangent. So you can always be on the lookout for those two fractions. Here, so this one's I'm trying to find one with a fraction in it, so let me skip over this one. Yeah, this is a good one to do. Okay, we got first step is to use the even and odd properties. Cosine negative x is cosine x. 1 plus sine of x is what the denominator is now. Because cosine is even, it means if you put a negative number in, same thing as putting a positive number in. Sine is odd, so it means if you put a negative number in, you get out a negative number on the outside. So here, let me write that out in case we haven't seen that video yet. Sine negative x is negative sine x. Okay, so that's why that changed to a plus, because a negative times a negative makes a positive. So that's my first step, and that's what they really want us to be practicing here. That's using the even and odd properties. Okay, let's see here. We need it to equal secant x minus tangent x. So there's one way I usually do these. I multiply the denominator by, I would multiply the top and the bottom by 1 minus sine x. I'm thinking if that's the quickest way. I think that is, yeah, because that'll give us two terms up top. So one trick we can try is you can always multiply by 1. I'm going to multiply by 1 in the form of 1 minus sine x up top and 1 minus sine x on bottom, okay? That's multiplying by 1 because the top and the bottom are the same. And so what that's going to do for us, see how it's almost the same thing as the bottom, except instead of a plus, I have a minus. That's going to allow us to eventually use a Pythagorean identity. We're taking this whole denominator and we're multiplying by 1 minus sine x. So this is the next part I'd want to type in Newton. Eventually, that'll let us use the Pythagorean identity. So we're multiplying by 1. That's just an algebra trick. And now we can distribute. We can multiply the cosine x to everything over here. That's, again, algebra. Okay, distributed cosine to the bottom. And then if you multiply these out, using FOIL or whatever parentheses method you want, just make sure 1 times sine of x, 1 times negative sine x, sorry, I think I said 1 times 1, 1 times negative sine x times 1, sine x times negative sine x. You're going to get 1 minus sine x plus sine x minus sine squared x. Okay, and again, that's just algebra. Okay, now we're going to be able to combine like terms in the denominator. At least the numerator has to stay the same. Now in the denominator, we got 1 minus sine squared x. Okay, again, it's just algebra because we, we had negative sine x plus sine x. That makes nothing, makes 0. All right, run out of room. Put that up top there. Let's see. So 1 minus sine squared x. We have, if something's squared, that hints at the Pythagorean identities, right? We have this Pythagorean identity. Now, you can rearrange this. You can subtract sine squared x from both sides, just like we did in that previous question. You get cosine squared x equals 1 minus sine squared x. So cosine x is what the denominator equals. Okay, so we're going to say it's still the same at the top. We haven't changed anything there. Actually, yeah, no, we should do those in separate steps. I was going to do two things at once, but Alex doesn't like that. 1 minus sine squared x is cosine squared x. So we use the Pythagorean identity. We get cosine squared x. The rule is the Pythagorean rule. Okay, and now if we want to do a little bit more algebra trickery, look at the top. We have cosine x in both terms in the top, so let's factor out cosine x. So you get 1 minus sine x when you do that. Still have a cosine squared x on bottom, so we just did algebra. We rearranged. That's algebra. And now look at cosine x on top, and one of the cosine x on bottom can cancel out. So we got 1 minus sine x over cosine x, and that's algebra again. Okay, so we're almost home, okay? Now we can break this up in two separate fractions. 1 over cosine x minus sine x over cosine x. And again, that's algebra, okay? I forgot it doesn't like that. Oops. So we used algebra, we rewrote the fraction. And now we can use the reciprocal. 1 over cosine, that's secant. One over cosine is secant, so we use the reciprocal. And now sine over cosine, that's tangent x. So that's using the quotient. Okay, bit of a long one there. There's always different ways of doing a proof, though. So, that might not have been the quickest way. There are other options too, but eventually you'll like the more you do these, you'll see like a trick that you can use. It could work, but it just might not be the best proof. I have a feeling that this many steps is probably not the shortest way, but that was just kind of the intuition that I had for doing it. Okay, so if you have a specific proof you want me to do for you, just let me know.